Yeah, sure. So I'm a Solidity developer, and I'm a smart contract standards author. And I'm also CTO of Pixelcraft Studios, which is making a NFT DeFi-based game. So that's yeah. Oh yeah, and so today I'm going to give a high-level overview of the Diamond standard, which is standard and contract pattern, and I'm going to kind of show you what it's about, what it solves, and what it is. All right, so first I just want to cover contract standards in general. I don't know how familiar people are with it. So most standards, as you can see here, they have their EIP and then some number. So EIP is Ethereum Improvement Proposal, and it's just how they name standards and how Ethereum does it. And so my definition of a contract standard is a smart contract standard specifies a general solution for a problem and specific contract interfaces and events to use that enable interoperability with other contracts and software. So you have a problem, and then you have a solution, and then that solution enables interoperability with different software. So that's, to me, that's what a contract standard is. Sometimes you'll see standards with named ERC, like ERC-20, for example, or ERC-721. So contract standards are sometimes called that. It's called Ethereum Request for Comments. But EIP is used interchangeably with ERC, so they're the same thing. So EIP-20, ERC-20, same thing. So that's just a little bit like what a contract standard is. Okay. All right, so then I just want to give a really quick, this is a really simple example of a contract standard. This is EIP 173. So this solves the problem of how do you own a contract, or so that you can control it, and then how do you transfer that ownership. So that's the problem, and then you can see the interface here below that people can then implement. You implement this interface to solve that problem, and then everybody uses this same interface. You can then create tools or user interfaces that can then use these functions to transfer ownership or show ownership of contracts. So this is that simple example of a contract standard. Okay, so now I'm going to get into the diamond. So then I'm going to get into some of the problems that the diamond is designed to solve. So one of the main problems that it's designed to solve is a contract size limit. When you're making a contract, the size of the contract, the actual byte code, it's not like a gas limit issue, but contracts, the byte code can only get so big, and then once it reaches that 24 kilobyte limit, then you can't deploy it. And some contracts, you want to have all the functionality in one contract, like an NFT contract that has a lot of functionality. It doesn't make sense to break it up into other contracts. So the diamond is designed to solve that. So you can essentially have one Ethereum address, so it's like one contract, but you can have a lot of functionality in it, and you're not limited. So that's like the most obvious solution. That's the most obvious problem the diamond standard solves, but I found it solves some other things. It makes some other things easier. And so one of them is it organizes contract functionality, a systematic way to isolate, compartment different functionality and connect them together and share data between them as needed in a gas efficient way. It adds structure. So you have a lot of contract functionality. It's good to be able to have it organized, structured in a way that makes sense. And the diamond standard, the way it works, helps you do that. This is also useful if you're going to be bringing on new people onto a project, because if you're kind of organizing things the same way, then if other people are familiar with the diamond standard, then they can get up to speed on your project faster if it's a diamond, because things are organized using the same structure. Okay, so another thing I found is that the diamond standard helps ease integration with user interfaces and other contracts by reducing contract functionality to a single Ethereum address that does not change. So I found that when you're developing smart contracts, And then you need to give the addresses of your contracts to like user interface designers or to other people who want to interact with your contract. It's much easier to just give them one address instead of like 5 different addresses for different things. So that's something that I found is useful. Also, you can have a diamond, and if you want, you can upgrade it, and you use your address stays the same, so you don't have to update your address in different places. You can just upgrade your diamond. Okay, good. So then 4, flexible upgrades. So with a diamond, as I said, you can have a lot of contract functionality, and you might want to add some functionality. Well, you can add functionality to a diamond without having to redeploy everything. You can just deploy what your new functionality is, and just add that to the diamond. So that's simpler than having to redeploy everything, and can be less expensive too. So then also, if you have a diamond and you want to remove something or replace something, you can just remove or replace it. And you don't have to remove and replace or deal with other things that you're not trying to upgrade. All right, and then oh yeah, so I also think it can make authentication easily, or like contract permissions, because if you have a number of contracts that are all connected to each other, and you have the situation where one contract gives permission to another contract to call into it, and then you have another contract that has different permission, and then you can have the system of permissions. But if you use a diamond, you're just using one address with a lot of functionality, and you can tie all your functionality to a single authentication system. So I just think it can make simpler permissions or authentication with a diamond, because you can have it all use one thing instead of having to do a bunch of different permissions for different contracts. So there's that, but the diamond doesn't enforce any kind of permission or authentication system. It doesn't specify that, and there can be a lot of different ways permission or authentication can be done with diamonds. So these are some problems it solves. It solves organizing contracts, solves the max contract size, eases integration, flexible upgrades, makes authentication easier. There could probably be other benefits too, but these are some of the main ones I've seen, so I put them there. Okay, so now I'm going to get into a little bit what is a diamond, and like how does it work. So a diamond is a contract with a fallback function. This is a solidity thing. And really most diamonds, and I prefer a diamond to have a fallback function and no other functions. And so if you're not familiar with it, a fallback function executes anytime a function call happens on your diamond, the fallback function executes. So it catches all function calls. Okay, so a diamond has a fallback function, and it borrows functions from other contracts. So you do a function call on a diamond, and the diamond goes, and then the fallback function executes. The fallback goes, oh, a function's been called on me. And then it's able to it has a mapping of another contract, and so it basically says, okay, function's been called on me. Where should I get the function for this? And so it gets the function from another contract, and then once it has a function, it executes it and returns the value. So that's how it works. So a diamond, it maps functions to contracts, and the contracts are called faucets with diamonds. So you have a mapping of function to faucet. So I know I'm kind of repeating myself, but just trying to make sure that this is understood, because this is the core of a diamond. Function is called on a diamond. Diamond finds, okay, where is this function? Gets the function, calls it, returns it. So a diamond can have any number of functions, and it can utilize any number of contracts or faucets to execute those functions. Okay, so here's a little diagram that shows it. So in the diamond, we have like func1. So that's like that just could be like a function. And anytime func1 is called on the diamond, the mapping says, oh, that's from this faucet here. And so it knows to to execute that function from this faucet. And so you can see the diamond can have different faucets for different functions. And so also as a note here, it says that upgrading a diamond is changing the function mapping. So maybe you have function 1, and when function 1 is called, it uses this contract with this address. And then to upgrade that function, you really just change the faucet address. So now it's using a different faucet for that same function. And to add functions, you just add to the mapping new functions that use different faucets or use faucets. Okay, so you kind of get the idea of how it works. It solves some of the problems it solves, but unfortunately, the diamond creates some new problems, but also solves them. And so one of the problems that happens with a diamond is that in Solidity, you can't declare and use state variables like you do normally with normal contracts because Solidity's built-in state variable layout doesn't work with diamonds. What's been created or invented is something called diamond storage, which is a pattern that allows you to create your own state variable namespace. You might say your own location and contract storage, where you can declare state variables and use them with diamonds, with faucets. There's another pattern called app storage, which is really just kind of another way to use diamond storage. That's easier to use app storage to share state variables between faucets. There's also another way to handle state variables with diamonds is to have a storage contract where you declare all your state variables in this one contract, and then you inherit that contract in all your faucets and in your diamond. So and that's another way. Okay, so that's one problem, is handling state variables in a diamond. So there's solutions for that. Another problem is that when you have a diamond and you go, you create verified source code on Etherscan or somewhere else, and you look at the diamond and you just see this fallback function, and you might go, yeah, but like what functions does the diamond have? And so the diamond standard includes a way to introspect into the diamond to get like, okay, this diamond has these functions that use these faucets. So, and it does this in two ways. The diamond has an event called diamond cut. And so anytime you add functions, replace or remove functions on a diamond, this diamond cut event is emitted that tracks all of this. So with the diamond cut, you can find every function, every faucet that has ever been added, removed, or replaced to a diamond. In addition, the diamond standard specifies 4 standard functions that you call them, and it tells you what functions the diamond has. It tells you what faucets are being used for those functions, and they're called these 4 standard functions are called the loop or loop functions. A loop is a magnifying glass that's used to look at diamonds, and so these functions look at your diamond and tell you what's in it and what does it have. Okay, so okay. Another, I put this down because this is a very common question. Let's say you have a diamond and you have a number of faucets, and the idea really with the faucet, part of the organizational strategy here is that you might have a certain set of functionality. Like maybe you have a ERC-20 token, okay, and that could be one faucet. All your ERC-20 functions go in one faucet, and but then let's say you want to have some other kind of function, some like DeFi protocol stuff, and another some kind of functionality that interacts with your ERC-20 token, or maybe a voting system. So you could create another faucet that includes all your voting functionality. And so this is kind of how you separate or isolate your different functionality in a diamond. You just create a different faucet for different things, and that helps you organize it. But what often comes up is you might have a function in one faucet that you want to call another faucet. So how do you share functions between faucets? And so this is often this is often asked, and there's actually a number of ways to do it. But the way I found best to solve that is to use Solidity libraries. And so in Solidity libraries, and I'm talking only using internal functions, not using public or external. So you use internal functions in libraries, and then this enables you you write an internal function in a library, and then you can use it in different faucets. That's really one of the easiest ways to share functions in a diamond. As far as diamond size, like a faucet, its bytecode only increases when you use an internal function for it. Like you might have a huge library, but it's not going to add to the bytecode of your faucet unless you use only the internal functions you actually use get added to the bytecode of a faucet. So it's something good to know. Okay, so to keep things simple, you can go read the standard. I have a URL here, but to make it simple, there's a lot of information about diamonds. It can seem complex, or there's a lot to it, and there's a lot to it, but really, there's also something really simple, and that's like what makes a diamond. And it's only a few things. Like to have a diamond, you only need a few things. You need to have a fallback function that that uses functions from other faucets or contracts. So I showed you the fallback function before. So you got a fallback function. It emits the diamond cut event anytime functions are added, replaced, or removed. Okay, so one event, fallback function, and then you have the loop functions, which the loop functions tell you what's in the diamond. You have those three things, then you have a diamond, and the rest, the rest is really like how you want to your diamond to work, your application functionality, how you're handling state, like that's all that stuff is up to you. There's solutions and stuff that you could utilize, but how you do things is really up to you. To make it a diamond, you need those three things. So that's pretty simple. And then, okay, I have notes here. Diamond cut event is great for tracking upgrades to diamonds. Loop functions are great and are very reliable for finding out what functions and faucets a diamond has now. The diamond standard also specifies a diamond cut function. This is for upgrading your diamond, for adding, replacing, removing functions. And it's an optional thing. So you could, if you want like tooling to be able to upgrade your diamonds, it makes sense to implement diamond cut, so that it's there for interoperability, so that if you're going to use a existing tool or library or project that upgrades diamonds, then you want to implement the standard diamond cut function so that the tools can use that. But if you wanted to create your own upgrade functions, then you could do that too. You just have to make sure you emit the diamond cut event. Yeah, it's also possible to create diamonds that don't have an upgrade function, so that you can create immutable diamonds. You just, like in the constructor of a diamond, you add the functions and faucets, and then once the diamond is created, it can't be changed anymore. Yes, and then so I also mentioned here, so the diamond cut event and loop function are standardized so that tools can use them. So some tools that can use the diamond cut event and the loop functions are testing tools, debugging, deployment, logging tools, data querying tools, and user interfaces. It is great if all tools and user interfaces for diamonds worked for all diamonds. And that's really the purpose of standardization here, is so that all tools can work with all diamonds. It's also helpful in if it's standardized and documented how diamonds work, then people can work together and come up to speed with projects that use diamonds. Okay, so here's the first user interface that I've seen made that works with diamonds. So you put in an address to a diamond, and then it will show you the faucets and functions that diamond has. And yeah, and then I think it also shows you something about it shows you an event where the functions were added. Okay, so this is just kind of like an overview of the diamond, what problems, what it is, how it works. Kind of skimming over, not going into detail about a lot of things, but so there's a lot more to learn. You know, like how state variable layout works is good to know. How diamond storage and app storage work. You know, so you can handle your state variables and your diamonds and faucets. How already deployed faucets can be reused by existing or new diamonds. And learning more about upgrades. There's a diamond standard Discord where there's people who know about diamonds and are building stuff are in that Discord, and so it's a good place to get help or to share things or find out what's going on. And then there's my blog, and I've written a number of blog posts about diamonds and faucets and about diamond storage and app storage. It's a good place to learn more things. And then the standard itself also has like a bunch of links to more documentation and useful stuff. Okay, so that's really I know I've gone pretty fast and stuff, but that's it. So I just want to say that yeah, and so as I'm CTO of Pixelcraft Studios, I'm making Aavegotchi, this DeFi-enabled crypto collectibles game. I'm building it on Polygon, not Ethereum, because we're making this really interactive game that and we want people to do lots of transactions. We don't want it to cost like $50 for users to do stuff. So we're building it on Polygon. Really great thing about Polygon is it's really compatible with Ethereum. So like it's just like I'm developing on Ethereum, but the gas fees are very low. And so we're doing that. And there's also a growing ecosystem of projects on Polygon. So, and also there's a bridge. So, and we're planning to do that where you can create Aavegotchis on Polygon, but then you can send them to Ethereum. So we're doing that too. Okay, questions.
Yeah, hey Nick, this is Hilma. First of all, great talk. Really learned a lot, and yeah, I'm a big fan of the Diamond standard. We will actually use it in Gelato in our upcoming V2, and I think I saw it first time kind of like a couple of months back, and then didn't really get around to research more about it. And then last week I dived more into it. I dove more into it, and really is very interesting. If you want to kind of like have upgradability, and if you want to have certain flexibility, especially at the beginning when you don't really anticipate how the project will look like or what functions or features you need, I think it's just much better than this traditional upgradability pattern where you have all the storage variables at the top and you always need to kind of like match them in the next few contracts you deploy. So yeah, I really like it. And yeah, I have a question or a few, but I will just maybe ask one and then see if there's some others. And one is you touched upon how you handle state in these contracts. I saw some examples of diamonds which basically use these libraries as sole pointers to the storage references of where the state is stored, and then just import the libraries and then don't actually have any internal functions in these libraries that they import. And so the kind of like the libraries are kind of like the storage pointers, and then you just make the reference in the actual facets. How are you usually doing it, or what would you recommend there? How to handle that?
Yeah, so that's example we were talking about there. It's a form of diamond storage. So that's you define a struct, and then you define your state variables in the struct. And now your struct can be it can be in a Solidity file, and you can just have a struct in a Solidity file, and then import that into wherever you want to use that. But it can also be in a library could be there too, and then the library can, like, you don't need to have a library there, but sometimes the library can have internal functions. You're saying it was a library, but it didn't have internal functions?
Yeah, it was literally just the storage pointer and the struct, and then basically all the functions were implemented in the actual facets. Yeah.
Okay, yeah, I see what you're saying. Yeah, it seems like it could be done either way, where you just have a file with the struct and then you use a pointer to that struct, but then you could have a library and then a struct defined in the library and then use the library to access the struct. Yeah. I would just use...
that was actually the case, yeah.
Okay. I haven't tried using a struct inside a library, so I don't know if there's any, like, omit, any additional benefit to that other than like it gives you like it makes it more explicit in your code, because then if you're going to use that somewhere, you're using the library name, and then and so you're adding a library name in your code, so it tells you like it helps explain to you like what it is. So maybe it's useful in that case. But I'd say either way, whatever makes sense.
Yeah, and maybe just like I think Luis, you can go after, just as a follow-up question. What I realized when building our diamond was that I was like, okay, I can just add this feature that I had on a separate contract right to the diamond. Oh, there's another one I want to add here, and then suddenly I ended up with like all the like our diamond was just like all the functions that we had on like 3-4 different contracts were all in one diamond, and this kind of like led to me thinking, where do you draw the line? What should be on the diamond and what should rather be stored maybe also in like a separate immutable storage somewhere else where you can't kind of like upgrade the functionality around it? Where you draw the line there?
Well, I'm still finding that out for myself, but I know what you're saying, because I was building Aavegotchi, we had our faucets and functionality, and then we realized, oh, we need a marketplace for Aavegotchi. And so first we thought, well, we'll make like a new project for that, like a new contract. But then it was like, it'd be really easy just to create a faucet contract in our existing diamond, and then it allows us to access all our data for all our Aavegotchi stuff. And so it's just so much simpler to do that. So that's what we did. So our marketplace for Aavegotchi is just another faucet into our main Aavegotchi diamond, and our main Aavegotchi diamond is getting bigger because it's so easy just to like add more functionality to it. I don't know where to draw the line on that. The line gets drawn for me already when like I have let's say I'm implementing ERC-20, but I also want to implement ERC-721. Well, you can't. ERC-20 and ERC-721, they have like the same function signatures for some of the same stuff, so you can't have a diamond with two functions with the same name and same arguments. So like so that gets to a thing like if I want ERC-20 functionality and ERC-721 functionality, I know I can't put them both in a diamond, so the line gets drawn there. But like with Aavegotchi, like ERC-721 and ERC-1155, which is this other, there's two different NFT standards. I can fit them all in one diamond because their functions do not clash or conflict. I don't have that problem. So that's where one line gets drawn, is when I need the same function name for different things, same function name, same arguments. But that's a good question on separate. I haven't figured out where the line is, where it's just like this diamond is too big. I need to use something else. Part of the thing is that because the diamond splits things into faucets, it really kind of makes things, you create these small units that are part of the big thing. And so it just seems like you can just keep doing that. So I don't know.
Okay, thanks.
Yeah.
Hi, Nick. Nice to meet you. Great talk. And I also saw the diamond standard a couple of times on Twitter, I think. And then I also encountered it in the documentation for hardhead deploy. So I actually asked Ronan about it, and he was kind of shilling it as well. Yeah, so now I finally got to actually reading your EIP proposal. And there was one little thing that kind of stuck in my mind. I'm not sure if I remember correctly, but is it so that you can also update functions on the proxy itself by somehow like putting the facet address to the proxy and then putting a function signature on there or something like that? I think maybe I misread that, but it was just floating around in my head, because one problem I had, like a really weird problem that I had with another upgradable proxy before, was that it didn't have a receive function on it. And later on, I realized that, and then I was like, okay, damn it, this proxy needs a receive function. I don't think this would fix it, because you can not add a function selector for a receive function. But yeah, is there something like that where you can also upgrade functions not on the facet but on the proxy itself?
That's a good question. No, with the diamond, you have the fallback, and then you can also add like other functions directly into the proxy, into the diamond. And those, you can't remove those. Those become, I call them immutable functions, because you can't add, if they're directly in the diamond along with the fallback, you can't add, replace, or remove them. So that's kind of why I kind of like, and I think it makes the diamond a bit more complicated to have, some of this hard-coded, these functions that are directly in there. So that's why I don't do that. But it's possible to do that if you have like, if for some reason you want functions that can never be, removed or replaced or changed, it's possible to put them in there. But yeah, so that so, and you can still do that with a diamond. You can put these, and it's still a diamond, so that doesn't like, you could do that or not do that. I don't do that, because it's just simpler if I just have like one sort of strategy for all the functions, so I don't have any special cases.
Yeah. And also another question. So with the transparent proxy pattern, that's the most used one still, right? The one with the unstructured storage, and then you basically inherit. With that one on Etherscan, there's this amazing proxy contract checker, it's called, like / proxy contract checker, and you can, with a verified proxy, you can just add the address there, and it will automatically like get the ABI of the implementation, and then you can like read as proxy and write as proxy, right? Is the idea that I don't think this exists yet for the diamond, right? Probably, but is the idea with these loop functions to have this be possible in the future, or?
Yeah, you're totally correct. Yes, the loop functions enable that. I love that functionality you're talking about on Etherscan, where you can call into these proxy contracts on Etherscan and stuff, read and write the proxy. And the loop functions enable you to do that with diamonds. We just need user interfaces to support that. And I've talked to Etherscan. They have interest in supporting the diamond, but I think they need to see more adoption of the diamond, and more adoption has been coming. More and more projects are doing it, and it's helpful for people to tell Etherscan that they want this. Like, but yeah, I know you're saying, yeah, that's one of the things the loop functions are designed for. Exactly, integration with user interfaces, integration with tooling. So that's a perfect use case. I can't wait to see that happen.
And we need to shill it, I guess, right?
Yeah, we got to shill that.
And also, just so you know, like for us, this isn't a limitation at the moment, because for our like upgrades, we use a Gnosis Safe multisig, right? So there you already can like put the diamond address, or the proxy address, I guess you call it, and any ABI of an implementation. So yeah, I think that should probably work. I'm not sure if it would work with the Gnosis Safe. I haven't tried it yet with a diamond, but I guess
it should work. It should work.
Yeah.
I think.
Yeah.
Yeah.
Then you already have a nice interface. Yeah.
Yeah. So in this presentation, I had this one slide that showed this user interface, and it's doing that. It's using the loop function. You put in the diamond address, and it uses the loop functions to get the faucet addresses, and then it gets those faucet addresses. It retrieves the ABI from Etherscan for those faucet addresses, and it has that ABI. It's then able to show the function names of the diamond. So in other words, you can do similar stuff. Yeah.
I think that was actually built by Ed, also Ed. Called What the Funk. And yeah, shout out to him. He did some really cool stuff there. I haven't personally used that myself, but when our Gelato Diamond is out, I will definitely give it a shot. June, I think you had some questions from YouTube, right? Or like a question there.
Oh, she's on mute, looks like.
Oh, maybe.
There she is.
Yeah, someone's asking, since you already discussed your diamond standard with the DFO guys, I think they from Italy, right? Nick. Someone posting.
Oh, sorry. What are they saying? Are you able to paste it in the chat or something?
Yeah, they were saying. Yeah, someone's asking. So since you already discussed your diamond standard with the DFO guys, how would you compare the diamond standard with the microservice approach and double proxy? That's the question. I'm reading.
That's a great question, but I can't answer that because I heard about that stuff, but I haven't dug into that myself well enough to answer that. Just because I've been involved in other projects and stuff, but I would love to, and I hope someone can answer that. That's one of the things is with the diamond standards is I really appreciate and really love to see other people doing things with the diamond or writing things or comparing or building tools. I think that's fantastic, but I can't answer that question. I wish I could.
Okay.
Cool. Yeah, and I just have maybe one follow-up question.
Mhm.
And it's more about not maybe specifically about the diamond, but diamond is kind of like a tool, right, to create this upgradability and make it easier or more manageable, I would say, for developers. And it goes back to drawing the line. Where do you draw the line in terms of what can really be upgradable in your systems and what should not be upgradable?
Yeah. Yeah, and it's really kind of like up to you, your users, you know, the use case. So I don't know. I mean, like, I was noticing that like the USDC token contract that has like over $4 billion worth of tokens in it is upgradable. So like that's upgradable. I mean, like if my contract, someone has a contract with $200,000 in it, then like that's a, you know, that's upgrade, you know, I think it depends on security too. Like if you have an upgradable contract, it's going to have a lot of funds in it. It could be upgradable, but you want to make sure your security is really tight, that there's no problems in your smart contract, like it's really well looked at. So, well, I mean, so it depends. I guess I get one, if it is upgradable and you do have one benefit of upgradability is if you do have a bug that gets found out later, you can fix it. Whereas if it's not upgradable, then you can't. So that's nice. So that's, again, that's really depends on the users, the use case. I don't know. I think a lot of factors on upgradability, whether it should be upgraded or not. One thing I do like about the diamond is it can be upgradable, and then at some point you can remove the upgrade function, and now it's not upgradable anymore. So that could be something to help. That could be a strategy, and that users could like that. Like if you have a diamond that says running well for 3 months, everybody knows there's no changes. You can make it immutable, and then that makes it even better in that case.
I have one. This is more like a deep solidity question, but when we coded, we also used the Gnosis tape a lot, and we realized, and actually this is a very little known fact by Solidity developers. Like we talked to some of the best Solidity developers out there, and they weren't aware of this, but we realized that because in a delegate call framework, things get a bit more complex, right, to reason about. And one such thing that caused us headaches, and that is usually a bug also in other systems, like one of the Gnosis tape modules, like the multi-send one, we found that it wasn't a very dangerous bug, but it was still a bug, is that with a delegate call, if you have a message value, right? So if you want to make a call to some payable function that might accept some ETH and transfer it somewhere, and you want to batch calls, then all the other functions in that batch also need to be payable. And this is because in the delegate call, you retain the context, right? You have one message value, and if it's non-zero and you're trying to make calls to like function selectors that are like non-payable, you will get a revert because you're trying to call a function with message value, even though if you think about it, it's like not intuitive because basically, long story short, if you want to batch calls to like 4 functions and only one of them needs a message value, all the others, if they are on a contract, also need to be payable. And this is really annoying because then you need to make your contract functions payable, even though they shouldn't be payable, right? If you want them to be able to be batched. I'm not sure if you were aware of this. We only found out because we ran into these problems by accident. But I was thinking, so I talked to Chris Eve about this, the guy from the Solidity team. And one way to circumvent this restriction is to use libraries, like with external functions, because the way the EVM handles libraries is that it bypasses this call value check. That's why basically you can then make batch calls, and one of them can still have like a message value, and all the others don't have to do that. And I wanted to ask you, like in general, when building these modular systems, I sometimes realize that even these facets, right, they're not supposed to keep their own state. So if they're all stateless, why not just use Solidity libraries instead of contracts? And one such advantage would then be to bypass such call value checks with library functions. The only reason I don't use it is because there's complexity involved, like linking at deploy time or something I haven't tried out yet. But have you thought about this? Do you think that stateless facets should also be just libraries that are deployed to the EVM, or is this also new territory for you?
Well, that scenario with sending either, I didn't know about, and I think that's interesting. I think that's good to know. And as far as using, I think as far as just using like external functions in libraries, I don't know. Maybe there's some good patterns there. I don't know on that. I do like using internal functions with Solidity libraries with diamonds, in order to share functionality between faucets. I like that. Now, another approach, maybe it's not workable in your scenario about this this problem with sending either around, is I like to work with ERC20 tokens, and so like I try to avoid sending either around. Like I'd want to work with like wrapped ether. So I'd like if I try to like, if I had ether into the contract, I'd convert it into wrapped ether, and now it's an ERC20 token, and now I can send it or treat it. Now I can treat it as that, and that's a lot easier. Maybe at the end, like if it's the ether is supposed to come out somewhere or something, maybe it can be converted back to ether, converted back from wrapped ether into ether or something like that. But that's my
not at these gas prices.
Oh yeah, good point. Yeah.
But yeah, this would be I mean, this pattern is now implemented in Uniswap v2, right? They also only use wrapped ether, so I guess it has its merits, but comes with some overhead for sure.
That's true. Yeah, I'm on Polygon. I'm on Polygon Network, or Polygon, which is Matic, in developing contracts there. It's the same as Ethereum, but there's a huge difference in that the gas is very, very low. So now, as a developer, I'm more free to like to do functionality in the smart contracts because that I couldn't do on Ethereum because I'm not limited by gas. And so like, anyways, I just mentioned that. So I feel like it's even better to develop on Polygon in that respect because it's more flexibility. But I like Ethereum too. Go ahead.
Yeah, but do you now spend? I get that you're a game developer, right, on Ethereum?
I guess I am. Yeah. I mean, I'm a Solidity developer, and so I've done different kinds of Solidity contracts. But I am with the Pixelcraft team making Aavegotchi, which is DeFi NFT game. And so that's why we're on Polygon, because users are going to do a lot of interactions, and we just need low gas fees. Good questions.
All right, I think June, do we have any more from YouTube or something? Otherwise, I think we are good.
Oh, I want to comment something on one thing that you mentioned on the upgradability. So another whole aspect to upgradability is specifying who can do upgrades, and that's very flexible. You could have kind of like a multi-signature thing where you can suggest an upgrade, and then 3 people have to submit transactions to approve that upgrade. You can have DAOs, do upgrade. So it's not like a single person, but a group of people can vote on an upgrade and have it all done on chain. So you could do time-based, where you can set it up so that upgrades can only happen once a month during 24 hours. I mean, so like that's just a commentary on upgrade. You can limit the upgrades in these different ways to make it better, more secure, or that kind of thing. Yeah,
definitely. That's I think it's an important point. And yeah, I think like diamonds that store a certain value shouldn't be upgradable by like a single person, right? That's a bit weird. Yeah, we should avoid that. At least have a multi-sig. Yeah. June, any other questions, or are we good?
Yeah, we are way over time, so I think we don't have any questions, but I think thanks Nick so much for joining us today. If you guys don't have any question, I think we can just end the live. Yeah.
Great, thank you.
Perfect. Awesome. All right. Thanks a lot, Nick.
Thanks.
It was really interesting.
You guys.
Thank you, guys.
Thank you.
All right. See ya.
See ya.
Bye-bye.
Okay, I just end the live.